Question 4. The first part. It is a binomial distribution with n is 432,286 and the p is 0.003. So we know that the expectation of b is np, so it can be approximated as 1,297, and the variance of b is np1 minus p, so it can be approximated as 1,297 times 0.997, so it is about 1,293. So this is first part. The second part, the probability of b is greater than 3,407 is the probability that b minus the expectation greater or equal to 2,110. And because p is non-negative, so this probability is equal to the absolute value of b minus 1,297 and greater than 2,110. And we can use Chebyshev inequality, and this is smaller or equal to the variance is 1,293 over 2,110 square, and this value is about 0.0003, and we can see that this value is very small. Okay, so this is the second part. For the third part, the probability that at least one county has 3,407 votes is the 1 minus the probability that no county has at least 3,407 votes. So this is 1 minus 0.0003 to the power of 67, and we can calculate this probability is about 0.02, is 2%. So this is still very low, but of course it is larger than 0.0003. Okay, for the last part, we can see that originally among 100% voters, there are 0.3% will vote Buchanan, but the new scenario is among 80% voters, there will be 0.3% voters vote to him, and the other 20% voters, there will be 1/6 probability to vote him. So we can see that the probability the voters vote Buchanan is higher. So from this observation, we know that the bound should be higher. Okay, this is question 4. But we can have another approach is, we know that P is higher. So if we check the alpha and the variance in the Chebyshev inequality, we know that alpha will be lower. And because P is smaller or equal to 1/2, we can also check that the variance NP1 minus P will become larger. So if we use Chebyshev inequality, we know that the variance of B over alpha squared. This is larger, this is smaller, so we know that the total bond is larger. So this is another approach for fourth part. So this is question number 4.